The purpose of this video is to define atomic number and atomic mass. On any given periodic table, there is an arrangement of squares, and in the squares, normally the symbol of a particular element is shown. In this case, C stands for carbon. On many types of tables, there will be a number above the symbol and a number below the symbol. In many cases, the number above the symbol is the atomic number. The atomic number gives us the number of protons associated with that particular element. The number of protons is important because it identifies the type of element. It's the identifying factor for that particular element. So in other words, no other element on the periodic table has 6 protons, only carbon does. And if we change the number of protons, then necessarily we've changed the identity of the element. So in other words, if we were dealing with an element, let's say had 7 protons instead of 6, then in fact we'd be dealing with nitrogen instead of carbon. The other thing that's important to realize about the atomic number is that when we talk about neutral atoms, and a neutral atom is an atom that has the same number of electrons as protons. The importance of this idea is to remember that protons have positive charges on them, and the electrons have negative charges. So anytime we're dealing with an element that has the same number of protons and electrons, that element is neutral. In other words, it does not carry a charge. So the atomic number for an element not only gives us the number of protons, but it also provides us with the number of electrons when we're dealing with the neutral element. Okay, next what I want to do is turn the subject to the atomic mass, and on most tables the atomic mass is going to be found below the symbol. Atomic mass is given in a couple of different kinds of units. One type of unit is the atomic mass unit. Another type of unit is when we're talking about molar mass, which in that case is grams per mole. The subject of this video is not on the units of atomic mass. Instead, what I want to do is talk about what this value actually means in a qualitative sense. So let's go ahead and define it. Atomic mass is going to be a weighted average of individual elements within a group of elements, taking into account the abundance of the isotopes. So for example, a sample of carbon taken from the crust of the Earth is going to be comprised of 3 different isotopes: carbon-12, carbon-13, and carbon-14. The atomic mass takes into account the abundance of each of those isotopes and gives an average mass that's been weighted for the abundance of each of the isotopes. So let's see how this works. So there are 3 isotopes of carbon: carbon-12, carbon-13, and carbon-14. In a sample of carbon dug up from the crust of the Earth, 98.9% of those atoms are going to be C12. C12 isotopes have 6 neutrons. C13 will comprise about 1.1% of that total sample. So let's just say we round it up to 100 atoms of carbon on a tabletop. In 100 atoms of carbon, what this means is that approximately 99 of them are going to be C12s, and 1 of the atoms is going to be C13. C14 also occurs in trace amounts. For the sake of this presentation, we're going to go ahead and ignore it because it's present in vanishingly small amounts. So how do we find a weighted average? The vast majority of carbon found in the crust of the Earth is in the form of carbon-12. So we write down its mass, which is 12. Then we multiply by its abundance, which what I've done here is to divide 98.9 by 100. So we're using the decimal percentage, multiplying by 12, and then we're going to add that to the amount of C13 found in the sample. Again, we're going to utilize its mass, which is 13, and then we multiply by its abundance. The 2 numbers are then summed together to give the atomic mass of the total bulk material. So the atomic mass of carbon shown on the periodic table is what we call a weighted average. It takes into consideration the variations in mass due to isotopes.